Um, number the tangent of A equals -1. What are two possible values of sine A? So the first thing you have to do is figure out what A is, right? So in other words,
Oh shoot, I did this wrong. I did this way wrong.
oh, okay. Right, right.
Wait, so how do you do this?
Did you follow all that? Where on the unit circle? Where on the unit circle is the tangent -1?
0.
So you're looking at the little boxes there. So, and you're looking for the sign at that point. So sine is the second coordinate, the y coordinate. That is correct. It could be in quadrant 2 or quadrant 3. No, 4. Yes, plus or minus. Yes. What else? Anything?
If you just write it down, you have to use that.
You wouldn't know what.
Yeah. So like, I'm gonna assume you're gonna like cross multiply.
But I have to look if I don't have any ideas. Like I have to look at the tree.
Yes. 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 Yeah. 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 All right, y'all ready to do trig identities?
Let me think about this.
This is gonna be so straightforward, y'all.
Can we do 3 really quick? Because I didn't know how to do numbers.
What are we doing?
Trig derivatives.
Oh, we're not going over anymore.
Did anyone? I'm hesitant to even ask this. Did anyone watch the 2 videos I posted yesterday?
I saw them.
If we get through this in time, I'll run them through at the end of class for you to watch because they're only like 6 and 7 minutes long. They're not long, but it's on particle motion, and it's just a different perspective. Sometimes that helps. This might help.
Yeah. Like, well, like the stuff that we did for the last part of the I think that sounds a little bit first.
Yes, but we're gonna do some more practice. I actually have y'all 2 FRQs not run off, but I made them yesterday that we're gonna do together that are particle motion. We'll still do some more practice. I would really like to do them on Friday for Freaky Friday. FRQ Friday, Freaky Friday. Get it? Ha ha. Okay, let's talk about the trig derivatives. Hello, starving. I'm Miss McGee.
If I go to Chick-fil-A and I get you something, so I get myself something. Like I'll get you.
I don't want anything, but I can't.
I'll get the old fast.
All right, derivative of sine x. These are on the back of your derivative sheet. It's just cosine x. Normally, I would go through and prove this using the definition of the derivative. I can do that. Would you like me to? You want me to prove it using the difference quotient?
Yeah, go ahead. Go ahead.
That's the way we prove it. Okay, I was gonna say I can show you. It does not. The reason that I was not going to show you the proof of it is because it doesn't further your understanding of this. Showing you difference quotient in preparation for derivatives helps you understand what a derivative is, but using the difference quotient on sine x to show you how it comes back down to cosine x is kind of like completing the square on a quadratic and standard form and showing you that it's the quadratic
What are those
formula.
two graphs look like?
It doesn't help your understanding of this. No, it'll just, in some of the proofs you do.
What is,
All right, the derivative of sine x is cosine x. Just know that.
what are these two graphs?
You will commit these to memory.
What are these two graphs look like? What are these two graphs look like? Sine X and cosine X. Well, I forgot.
That's your sine and cosine curves. They go up to 1 and down to -1.
And the other one goes the other way.
It's just shifted over.
And that's the sine?
Well, it depends on where you put the.
So that's sine.
What's the sine of 0 and what's the cosine of 0?
Sine is 0. Sine of 0 is 1. Or is it 0?
0. Cosine of 0, 1. So this one, since it's at 1, this point is 0, 1. This would be which graph?
So,
Which one has a value of 1 at 0? Cosine. So that's cosine. Sine would start here. No. He just asked what the graph. Nope. We're just doing derivatives. All right. I'm writing these down. These are already on your sheet, so if you don't feel the need to write them down. Fan. Derivative of cosine x negative sine x. No, don't worry about that graph. Dylan was asking what the graphs look like. You do not have to. We're not doing that right now.
don't worry about it.
Don't worry.
The derivative of tangent x is secant squared. Tangent, remember, is sine over cosine. The derivative, and if we did this, and we might actually, I think you might actually do this in one of the problems. This one's a little bit easier. If you wrote tangent as sine over cosine, and then you did the quotient rule, right? Derivative of the top times the bottom minus, you would come back to secant squared. The derivative of tangent. All right, what is tangent? Watch, we're going to do that one. We'll do that one. Sine over cosine. Do we all agree? If I want to do the derivative of tangent x, use the quotient rule. Derivative of the top is what, Van? Cosine x times the bottom minus right.
Wait, so the derivative of
All over, right?
So the derivative of cosine x is negative sine x?
Yes.
That's ridiculous.
So this is cosine squared x plus sine squared x over cosine squared x. Yes. Why is it 1, Lizzie? That's that Pythagorean identity.
Or you can just fill us out with cosine. Why can't you just fill us out with cosine?
What? You can't because you're killing kittens, Dylan.
I love killing kids.
Wait, that doesn't make sense. Like, that's not the same.
That's still not the same. What's not the same about it? Well, 1 over cosine, do you agree, is the same thing as secant?
Yeah.
So this is secant squared x. So the derivative of tangent x is secant squared x. Yeah.
Go back up. Why'd you write it? Oh.
Yes. Sine squared plus cosine squared equals 1. Y'all are a bunch of clowns. Not everyone.
This doesn't sound like
The
it's
boys.
serious. I think I'm in the middle of the ocean and I hear one out.
All right, let's do the next one.
I promise it's not me. I'm not even.
I'm going to try to do a few of these with you. If I can get through it. If you need it, you talking about this one? I ran a couple extra on this desk in front of Lizzie. Oh. Did I run you a trick identity sheet? Oh, I can run it again if
Wait,
I.
is it laminated?
Oh. All right, the derivative of secant x equals. We did the derivative of tangent x is secant squared. So the derivative of secant x, and this is on your sheet, I think. Look, y'all, follow. It's on your sheet.
I just said it.
It's on your sheet. It's on your sheet.
I thought about it in my head. I just got it like that.
You'll be proving these in several of the problems for homework tonight. These ones that are we didn't prove the sine and cosine and tangent, but using those, it's easy to prove all the others.
Like a train.
We'll prove it. Let me give them to you, and then we'll go through and work through a couple of them as to why. The derivative of, which is nice because if you get stuck and can't remember one of the cofunctions and derivatives, you can always work through it. All right, so we did sine, cosine, tangent, secant. Let's do cosecant. Yeah, no, 1 over cosine. Cosecant is 1 over sine. So the derivative of this one would be negative cosecant cotangent. This is not a very common one, not as common as the others. But again, you can always derive it if you do. If it's 1 over sine x, you can derive that with the quotient rule. Yeah. Yes. Well, the cofunctions you could derive them, but the first 3, sine, cosine, tangent, you really can. You'll use them so much though, you'll remember. Especially, I got to do it. Okay, they will be on the test, but the test is not tomorrow. Y'all. No, you'll have to know these.
What about the first sheet that we got? Was like, oh.
Nope. Good. Shut your mouth. Why even ask?
Like question ones and like.
Oh, no. I'm sorry. You won't use the. All right, let's do some problems. Y'all are rare form today.
Yeah, we don't even know how to use this.
That's what I'm fixing to show you.
What?
You're welcome.
Exactly. That's what I like to see.
I'm going to work through a couple of the evens with you here from your homework. It's number 2.
Wait, can you scroll up? I didn't get that one. Okay.
Number 2 on which page is?
Yeah, I'll tell you, Rick. It was negative cosecant squared x.
What numbers are for the homework again?
Find dy dx. Oh, this is.
Is this the beginning of our homework?
Yeah. Don't say it out loud whenever you get it.
Wait, is that the first question? Like, I don't
Number 1 is the first question. This is number 2. I was just working through some of the evens with you and letting you do the odds.
Never told us how to do it. How are we supposed to know? Easy now, Ben. Know you're closer. A little more. Nah, but real talk. How are we supposed to?
Maybe like the other one.
All right. If there's a coefficient in front, that can come around, right? The derivative of,
Oh, it's the reverse power rule.
this is the same thing as 2 times the derivative of sine x. Do you agree? Okay. So what is the derivative of sine x? So this would be 2 cosine x. What's the derivative of tan x? That's all you do. You're using, that's what I said, these are literal just memorize and plug them in things. No, there's no way to simplify that one. If there were a way, so if you're in an FRQ situation, no, you never simplify past what you have to. But if you're on a multiple choice, you'd have to know, you'd have to be able to manipulate it a little bit. Let's do number 4. Find dy dx. Y'all stop with the wells. I don't know.
It's not me, it's coming from over there.
X is not a constant this time, so I can't just pull it around front. So it looks like this might be a product rule situation.
I don't think so. I think you can just turn it into secant x tan x with an x. Can you do that?
Well, let's see. The derivative, I'm multiplying. So derivative of the first times the second plus the first product rule. Yep. What's the derivative of secant x?
Secant.
That's it.
Yes,
No.
You can't do like secant x.
Well, there's no plus in there, Ren. What are you going to multiply out? This is just secant x plus x times secant x tangent x. If you would like to, sure.
Wait, wouldn't that,
If you want to, but why are you making so much work on yourself?
wait, wouldn't that x have to go to both terms?
No, because there's no plus in the middle. That's multiplication. If this was a plus here, yes, it would go to both. But because I'm multiplying right here, and I'm multiplying right here, why would you make it secant squared? Y'all are trying to do too much with it now.
Yeah,
Too
but
much.
this is what I don't like, because now it's just memorization.
This part is memorization. But it's memorizing those, really you just have to memorize the 3. It's kind of like the unit circle. If you memorize the first quadrant, sine, cosine, tangent, you can get to the others. We did. We did, Meg, we did.
You know your ABCs?
Dylan,
What about what?
find the derivative, find dy dx.
How will it? See, that's what's going on.
Don't get him started.
Nobody showed up to answer.
Nobody.
It's derivative of the first. It's derivative of the first. I get on first plus
Times the second.
times the second and then derivative.
Plus
Plus
the first times the derivative.
Wait, is it plus, right?
Ah,
Just go for a second. Miss McGee, let me get it real quick.
don't look up. I'm not going to talk through it.
Well, I want to.
Is it over anything? I did it right.
The 3x is easy. It's just 3. Derivative of the first times the second plus the first times derivative of the second. There's not really anything else I can do with this, but just write it exactly that way.
What I got.
One more, and then I'm going to move on to some a little bit harder
Wait,
ones.
I do have one question. Why is that one not an x?
Derivative of
But
the
it's the derivative of the first.
What's the derivative of x?
Well, I thought the first thing was 3.
I already got that. No, you can't do that. We're doing product. We're doing product.
We did this, and we're done with it. Now we find the derivative of this.
I thought it was the derivative of the first times the second. Yes, of the thing multiplied.
Right.
And the x and the x.
This is product rule.
If you have,
Not addition.
this is your u and this is your v, so you do the derivative of the first times the second. First times derivative of the second. All right. Uno mas. 10. Find dy dx.
So it's the derivative of first times the second all over p squared.
So do, yes.
Wait, and you just throw the whole bottom into it. Like 1 plus sine x, you put that.
That is the whole bottom.
I know. So you would do the derivative of cosine x plus the whole bottom?
Yes, times the whole bottom.
So yeah.
And this is where we will need to manipulate just a little bit here. Ah!
Over p squared.
Leave that bottom like that. Don't try to foil that out and everything else. I just may not need to. Yeah, it's really, when it's like that and it's in factored form, it's really pretty simplified already. Because that's what you generally try to get to is a factored form like
Wait,
that.
Mr. McGee, I do have a question. Why wouldn't the second part be cosine x times sine x?
The derivative of the bottom would be cosine x.
But the top is other motion, right? Oh.
This would be negative sine x minus sine squared x minus cosine squared x all over 1 plus sine x squared. Well, what do you notice
Wait,
here?
hold on. How did you get minus sine squared x? How did you get that?
How did I get what?
Minus sine squared x.
I distributed those.
So you pull out the negative 1.
Why am I doing that?
Negative substitute on the top. Like the negative 1.
I just wanted to show you what. Hold on. Anytime you see this, and this is the most common like this happens all the time. When you ever see sine squared and cosine squared together, try to get it to be 1. Try to get it to go to 1, because more than likely that's what's happening. And here that is what's happening.
What do you mean by trying to get it?
because it was negative, but I could take a negative one out, make them both positive, and sine squared x plus cosine squared x is always 1.
Negative 1 over sine x plus 1. Yes. Yes. Canceling a sine x plus 1.
Oh, yes. All right, so look, now I've got this negative out front, right? And this is sine x plus 1. Do you agree with that? Do you agree that these are the same thing? So I'm going to cancel this and one of these. Because this is the same thing as saying 1 plus sine x twice.
Wait, can you scroll back up a little bit? Sorry.
No, because this is 1 plus sine x. And so I could cancel out the entire. As long as every plus or minus is completely enclosed in parentheses, you can cancel out whole parentheses. That's the rule of thumb, though. Your plus or minus is not enclosed in parentheses, and you start canceling out terms. Right. What you mean?
Like, you have negative 1 plus 1.
Yes, yes, yes.
You don't want to kill it. Well, I didn't fucking kill it. Whoops.
Hey! One circle is good.
I got 2 more I want to show you. Yeah, that's it. That's it. Actually, I'm gonna leave you to those 2. Actually, I'll do one of them with you. This is number 26. I'm gonna do A with you. I'm gonna leave you with B. Prove that this is true using only the knowledge that the derivative of sine x is cosine and the derivative of cosine is negative sine.
I do have a question. Is this are these the numbers that are on the homework? If not, I need to we jump from 10 to 26.
It's 1 through 10 and then 21 to 30.
You said knowing that what?
Knowing that the derivative of sine is cosine and the derivative of cosine is negative sine, prove that the derivative of cotangent is actually negative cosecant squared.
Are we allowed to know what cotangent is?
Yeah. It's cosine over sine. Using the only derivatives you can use are the sine, derivative of sine is cosine and derivative of cosine is negative sine. Using only those 2 derivatives. Now you can use any other trig property that you know. Prove that the derivative of cotangent is negative cosecant squared.
I mean, that's what we do.
This is what we do. Remember, I'll give you a hint before you start.
Cotangent is
What is
1
cosecant
over.
equal again? 1 over sine? I already got that.
1 over tangent, and if tangent is sine over cosine, then 1 over tangent would be cosine over sine. That's your best place to start there with this one.
Isn't cosecant 1 over sine?
Yes.
Well, you get
Yeah.
you get negative sine x over cosine x. Then what? You get negative.
What you mean the answer?
There is no really the answer.
Oh, yeah, what on the Leah's list, so people off.
Wait, Miss McGee.
Oh, we're supposed to.
Why wouldn't you go ahead and do the derivative of those? And then like you get negative sine x on top and cosine x.
You can't, because you got a quotient. You can't just take the derivative of each one. You'd have to use the quotient rule.
That is just.
right?
Where'd you get negative sine x? Where'd you get negative sine x?
Oh, the derivative.
A derivative, yes.
Think of it. Take a deep.
Dylan, can I cancel those sine squareds out?
No.
No. I'm sorry. Okay. I'll give you a minute.
Okay.
I'm going to wait on Van just a second.
All right, let's see.
Into the thick of it.
Let's see here. I see a sine x.
Who are you laughing at, Lindsay?
I see a sine x and a cosine x.
What did he say? I didn't hear it. That means something ugly? Oh. Yeah. I don't know. Somebody said something and it almost sounded like it was that tune.
What about
I thought you were laughing at Dylan.
cosine 2x equals cosine squared x minus sine squared x?
You are way overthinking this, Dylan.
Okay, well, what about,
How about what we just did on the last problem?
sine squared x plus cosine squared x equals 1?
Yeah, I got into a fight.
Did you all get back to this point? Part B, you're going to be proving that the derivative of secant x is secant x tangent x. So remember, secant x is 1 over what?
Whatever.
Cosine.
1 over cosine. All right, I got one more thing to talk you through, and then I'm going to show you those couple videos before you leave. Yeah.
Wait, we got to do the video.
No, you're going to be.
So we're doing one by
It was the chloroform.
Mr. Glizzy, can you please?
No, 100%. Actually, I'm just going to talk you through 28 before I show you the videos. 28, show that the graphs of y equals tan x and y equals cotangent x have no horizontal tangents. So how could you show that they have no horizontal tangents? What happens at horizontal tangents? What's 0? The slope, which means the derivative is 0, right?
Yes.
So if you can graph the derivative of tangent x and cotangent x and show that they never cross the x-axis, you can show they have no horizontal
Wouldn't the
asymptotes.
derivative of a cotangent x be
You can show that on the calculator, yeah.
Wouldn't it?
That's a gray one, but I would argue that that's not a gray one. All right, y equals tan x and y equals cotangent x have no horizontal asymptotes, and they want you, or no horizontal tangents. They want you to show that they have no horizontal tangents. So to show that, what I would do is I would look at the graph of the derivative, because any x-intercepts, any zeros there, right, would be horizontal tangents. So if it doesn't have any zeros, it doesn't have any horizontal tangents. Does that make sense?
Why do we need
Because
a
could you
graph?
have a horizontal tangent at 1? Oh, wait, never mind.
You're graphing the derivative, though. Not
Why would we graph the derivative though? Why can't you graph like tangent x?
Well, so you could graph tangent x and you could graph cotangent x, and you could say because this function is always increasing, it has no maxes or mins, so it would have no horizontal tangents. You could say that as well.
That's what I was thinking.
Either way.
Wouldn't
Either
it-
way
wouldn't
would
it be parabolas?
justify. No, tangent x is the one that has the asymptotes like this. And
Yeah, I know it. Let's look at the derivative. The derivative of tangent.
it would look close. You can graph it, do your inderiv on your, well, actually, you don't even have to do inderiv. What is the derivative of tangent? secant squared. So you could graph secant squared. Yeah.
But couldn't you just put the derivative of tan x?
Yeah, that's a lot more
Yeah, I
work.
would have to go,
All right, so we did about half of those with you. So you got about 15 problems tonight.
okay, well, can I
And
just,
some of these are really straightforward.
well, I'm just gonna